Hello and welcome to the video. In this video, let's try to solve this example. It is given that a causal system has an input x of n and the corresponding output is y of n. Now it is asked to find the impulse response of the system if the value of input is given by delta of n plus 1 by 4 delta of n minus 1 minus 1 by 8 delta of n minus 2 and y of n is given by delta of n minus 3 by 4 delta of n minus 1. Let's try to make use of the Z transform approach for finding the solution. Now, the idea is as follows. Since I'm supposed to find the impulse response is given by h of n. So I'm going to select the pen color here and get started. So h of n is going to indicate the impulse response. Now, if I take the Z transform of x of n, I'm going to get x of z. Z transform of y of n gets me y of z. We know the fact that the system function h of z is given by y of z divided by x of z. So the idea is very simple and straightforward. I should find the z transform of y of n. I should find the z transform of x of n, divide one by the other to get the system response h of z. Now, if I take the inverse z transform, I'm going to get the impulse response h of n. So that is what I'm going to do now. So initially, let's try to find the z transform of each one of them. So x of z is going to be very simple. We know that the z transform of delta of n is going to be unity plus 1 by 4. Z transform of delta of n minus 1 is given by z to the power minus 1 minus 1 by 8. Z transform of delta of n minus 2 is given by z to the power minus 2. So this is x of z. Similarly, when we try to find the z transform of y of n, that is y of z, it will be 1 minus 3 by 4 z to the power minus 1. Therefore, let me look at the system function h of z. H of z is given by y of z divided by x of z. That means this is going to be equal to 1 minus 3 by 4 z is to minus 1 divided by 1 plus 1 by 4 z to the power minus 1 minus 1 by 8 z to the power minus 2. Now it is very easy for us to see that h of z is given by this equation. Now if I try to solve for h of z so as to find h of n, I would require the simplified form of this. So I'm going to go with the partial fraction expansion method of this particular expression, and I arrive at the numerator, which is 1 minus 3 by 4 z to the power minus 1 divided by, if you carefully look at the denominator's factors, they are 1 minus 1 by 4 z to the power minus 1, and the second term would be 1 plus 1 by 2 z to the power minus 1. So these are the two factors. Now it is very easy for me to make use of the partial fraction expansion method. I'm going to write this as a divided by 1 minus 1 by 4 z inverse plus b divided by 1 plus 1 by 2 z inverse. Now we make use of the same method as we did it earlier. So if I have to find the value of a is given by h of z into the denominator, which is 1 minus 1 by 4 z inverse. Now this particular expression must be evaluated at the value of z equal to 1 by 4. Z equal to 1 by 4 because 1 by 4 happens to be the coefficient of z inverse or z inverse term over here. So if I write it, h of z is given by this entire expression, right? So this getting multiplied by 1 minus 1 by 4 z inverse will get me the numerator as 1 minus 3 by 4 z to the power minus 1 divided by, in the denominator, 1 minus 1 by 4, this term gets cancelled out. So I'm going to have only 1 plus 1 by 2 z to the power minus 1. Now this must be evaluated when the value of z is equal to 1 by 4. So I'm going to substitute the values over here. So this will be 1 minus 3 by 4. Now z inverse. So if z is equal to 1 by 4, obviously z inverse is going to be equal to 4 divided by 1 plus 1 by 2 into the value of z, which is equal to 4. So now this actually gets evaluated as minus 2 by 3. So this is the value of A. Once we get this, let's continue and look at the value of B. So the value of B is given by, as usual, h of z into the denominator of B is going to be 1 plus 1 by 2 z inverse. So I'm going to write it 1 plus 1 by 2 z inverse. Now this should be evaluated. If you go back and then see it, this should be evaluated at the value of z is equal to minus half. Why minus half? Because we always look at the value of this expression as 1 minus of minus half z inverse. So the coefficient of z inverse or z inverse is minus half, and hence we evaluate this. So referring back to the previous slide, uh, h of z is this. So the numerator is 1 minus 3 by 4 z inverse. I'm going to continue with that now. So this is equal to 1 minus 3 by 4 z to the power minus 1 divided by, now 1 plus half z inverse. Now this particular term gets cancelled out. So in the denominator, we will be left with 1 minus 1 by 4 z inverse. So that is what I'm going to write here now. As usual, this must be evaluated at the value of z is equal to minus 1 by 2. So if you look at it very carefully, I'm going to write it as 1 minus 3 by 4. If the value of z is minus half, z inverse is going to be minus 2, just the inverse of it. Then divided by 1 minus 1 by 4. So z inverse is going to be minus 2. So this actually evaluates to 5 by 3. So now, after I find the values of a and b, the idea is very simple and straightforward. Now, since I said h of z is equal to a by this particular denominator plus b by this denominator, I'm going to write it as follows. Therefore, h of z is equal to a, whose value is minus 2 by 3 divided by 1 minus 1 by 4 z inverse, plus I should write now the value of b. B is 5 divided by 3, and its denominator is 1 plus 1 by 2 z inverse. That is very simple and straightforward. Now for getting the value of h of n, I should take the inverse z transform of h of z. Now there is one important thing that you must observe here. It is given that the system is causal. Now this is a very important point you must always understand. It is given that the system is causal, which means that the value of h of n is equal to 0 for all negative values of n. So it means if I take the inverse z transform here, it cannot lead to a negative sided sequence or left sided sequence. So the answer is I need to get h of n, which is a right sided sequence. And hence, taking inverse z transform, I'm going to write it as h of n, which is the required impulse response, is equal to minus 2 by 3. We know that 1 divided by 1 minus alpha z inverse forms a z transform pair with alpha raised to n u of n. So this is meant for a causal system. So I'm going to write the same thing over here. So the z inverse z transform of 1 divided by 1 minus 1 by 4 z inverse will be equal to 1 by 4 raised to n u of n, plus as it is 5 by 3. I'm going to write it here. Now the equation is 1 divided by 1 minus of minus half z inverse. Once again, its inverse z transform is given by minus half raised to n u of n. So you can see here that the term 1 by 3 is common along with u of n. So I can just rearrange it a little bit and then try to write it as 1 by 3. Inside the bracket there is minus 2, and then the term 1 by 4 raised to n, plus there is the term 5 into minus half raised to n, and then entire thing getting multiplied by u of n. So this is the required impulse response of the system. Thank you for watching the video.